Okay, with variation, there are two main types of variation that we're going to look at, and I think we may have already kind of talked about this one a little bit because I know we have, but as far as like this is a little different look at some of the variation stuff that we've talked about. So here's the two that we're going to talk about. There's two main types, and there's a third type that's kind of a spinoff of the two. Okay, so we're going for the types of variation. Again, there's two main ones, and there's a third one that's kind of a spinoff of the one of the other ones that we're looking at. All right, so the very first one is we're going to look at inverse variation. And you may be saying, well, we've already talked about inverse variation at some point. And we have. We've talked about finding inverses of functions. So this is similar to this, but again, it's kind of going off in a little bit of a different direction here. When we're talking about inverse variation, this is basically what we're looking at, is that one variable is going to increase. While another variable decreases. All right, and if you get ready to start economics for my juniors in here, next year you'll do some. As seniors, you have to take an economics class, and this is one of the big things. This is the law of supply and demand. This is one of those things that drives basically our whole economy. That one variable is going to go up while another variable is going to go down. What happens to your spending money when the cost of gas goes to $4 a gallon? Okay, but as you're paying more for gas, the leftover spending money you have goes down, right? So it's kind of one of those things, and that kind of drives economic stuff. Think about the favorite artist that you had, that you'd like to go see. And I told you that tickets were $5, front row seats. Everybody's going to go for that, right? All right, now, what if we then take, so at $5 a ticket, fill in the blank, everybody wants to go, right? We got like thousands of people that want to go. I mean, tens of thousands of people want to go. What if we then turn around and say, all right, well, they realize that they're too cheap on the prices. Now ticket prices are $5,000 a ticket. Yeah. How many people are going to go now? The amount of people, a lot of people go, that's all right. I'm just going to watch I'm going to watch the burner version on YouTube. So. No. And that's, with inverse variation, that's basically what we're looking at, is that one variable is going to go up, one variable is going to go down. Okay, what this equation looks like, the general equation for an inverse variation. Is y equals k over x, where x and y are your variables, and k in this case is what they're going to call the constant of variation. Okay, that anytime you're working through something, you've always got to have some constant, that everybody's got something that when you're working through these things that's going to be the same, whether that's the price of electricity or the price of gas, or it could be that it's depending on the certain businesses you work with, it might be that it's the amount of pay that you can pay somebody. That sometimes there's always some certain constant that you have based on the equation to make things work out. So k is your constant, and x and y are your variables, where one's going to go up and one's going to go down. Okay, so one thing that you have to do with a lot of these variation equations that we go through, one of the very first things you have to do is you have to find k. You have to find that constant. So to find k from a general equation, if we were going to solve this thing for k, we'd multiply both sides by x, and that way the x's would cancel. So for this one, if we've got to figure out what the k value is going to be, that's going to be just x times y. Find k, comma, k is going to equal x times y, or y times x. All right, so for example one, we're going to do this. We're going to, and we'll do this one as like 2 or 3 pieces to kind of build up to a question of what we're going to look at. So for this one, to find the missing value of the, and they have to tell you somewhere along the way what type of relationship it's going to be, what type of variation is. In this case, it's going to be an inverse. It's the only one we've looked at so far. To find the missing value of the inverse relationship. With ordered pairs, 2, 5, and 4y. Okay, so they're telling you, all right, this is basically the graph of some type of inverse relationship that we have, and we've got to figure out what's going on with it. And the very first thing that you're going to do is you're going to use this first ordered pair that you have. We're going to use that first order pair to do that. So to determine k, use the first order pair with the equation. Again, to figure out what k is, it's x times y. And from that first order pair, we know that that's the x and that's the y value. So for this one, it makes it really pretty easy. That to figure out what the k value is, you just plug in the x and the y here. So that's 2 times 5. So your k value is 10. Okay. Again, that could be that it's the amount of, it could be the price per hour that you're going to pay somebody. So maybe you're paying somebody $10 an hour. And again, it may be one of those things that, there's some set standard that you've got to have when you're working through some things here. Okay, so they ask you to find the missing value of this inverse relationship. The very first thing you almost want to do in every single situation is figure out what your k value is. And there's almost always one ordered pair that you're going to be able to work with. And again, you'll use those 2 values to then figure out what the k value is going to be. The second thing you want to do, so that's step 1, to figure out what the k value is. Second thing we're going to do then is we're going to use the second order pair and your k value. So we figured out that k is equal to 10. So we're going to use that k value and the second order pair. And we're going to use that with the general equation of y equals k over x. Okay, so we've already used the first point, so it's out. So the only thing we've got left now is we know the k value is 10. We've got this order pair, which is x is 4 and y is we don't know. And that's how we're going to figure out what that missing value is, because now we're going to take this k equals 10, plug it back in here, take this x value of 4, plug it back in here, and then see what we can get. Oh, wait, I'm plugging in the wrong spot, didn't I? Oops, my bad. Hang on, got them crisscross there. K value goes there, x value goes there. All right, so y is 10 divided by 4. So then y is 2.5. Okay. Okay, so again, the big thing is with the inverse variation is that if you're setting up an equation, if you kind of look back here, that x was 2 and y was 5. The next order pair, x was 4. So if it's inverse, x gets bigger. So that means the y has to get smaller. So they're always going to go in opposite directions. So if we went from 2, 5 as order pair. So if x gets bigger, then y has to get smaller. And that's kind of what you want to think about as you're going through these. And that's kind of the setup that they're going to use for this to kind of get you an idea to see what's happening with it here. Okay, so that's inverse variation. That's kind of the basics of it. The second variation that we're going to look at is, besides inverse, we also have direct variation. Okay, so inverse, one variable is up, one variable is down. With direct variation, they're directly related. So whatever one variable does, the other variable is going to do the exact same thing. So we'll just say it this way: as one variable increases, or if you want to say on the flip side, as that first variable decreases, another variable does the same thing. Right. So as one variable increases, another variable increases, or as one variable decreases, another variable is going to decrease. So the variables work in the same direction. Okay, so direct variation, they both go in the same direction, where inverse variation, because it's inverse, they're opposite. One's going up, one's going down. Okay, in your general equation for direct variation, is y equals kx. Again, k is still that constant of variation, just like it was in inverse. And again, that with any equation you work through, there's always has to be some type of constant that it will kind of spin around as you go through these. All right, and to find k, all right, to get k by itself over here, now you're going to divide by x. So in this case, your k value is going to be y divided by x. All right, and again, it should just it's the opposite of inverse variation. So inverse and direct variation, everything is exactly kind of backwards when you go through these to find the different parts of it. Okay, and one of the examples that y'all have done for years that you just haven't really thought about it. Anybody remember what the formula is for area of a circle? Area equals pi r squared. Anybody remember that? Yeah. Yeah. Now you could do circumference. Yeah, circumference was pi times diameter. A lot of those are direct variation equations, because what happens if you make the radius of a circle bigger? The area also gets bigger, right? What happens if you increase the diameter of a circle? The circumference also is going to get bigger, right? So this is one of those things that an example of direct variation equation is area equals pi r squared. And y'all have done that stuff with years. And if you think about this one, what's the one thing that's the same no matter what you do in every single circle? You always use pi, right? So in that case, k is our 3.14 for that equation, because it doesn't matter if you use a circle that's a mile big or use a circle that's an inch big. Pi is still pi. It's still 3.14. So no matter what you do, there's always going to be that part of it right there. Okay, so that to me, that's one that people look at and go, oh, nobody ever told us that. No, because you didn't really have to worry about it back then. That was just trying to work with the formula. But that's a direct variation equation, that if you want to make the area bigger, you make the radius bigger. If you make the radius smaller, then the area also is going to get smaller. And no matter what you do, the one thing that's always the same is that pi, the 3.14, doesn't matter how big or how small a circle is, you always use that exact same number when you're working with area or circumference or anything with area of a circle or anything like that. Okay, so here's what we're gonna do. We're gonna do kind of the same thing we did on the last one, and we'll do kind of along the same line. Let's find the k value. Of the direct variation we'll say problem here. I don't know if that's the best wording ever or not, but we'll go with it. Find the k value of the direct variation problem with an ordered pair for a. Okay, and we'll look at some word problems here in a little bit where they change some of the wording up and you have to kind of dig through it. But if they just say, here's a direct variation equation, give you an ordered pair, they're just assuming that everything's kind of working. If you kind of look at direct variation and say if y equals kx, what if that was mx? Looks a little bit like slope, right? Y equals mx plus b kind of thing. So this is kind of similar. Now, again, you can change the variables and have it like this one. Well, obviously, it's not going to be r squared. It's not going to be a straight line. It's not going to be linear. But a lot of what we do with direct variation kind of spins off y equals mx plus b, where you would start at 0, and then you just use the m value or your k value kind of like slope in a way. So that's kind of where you're going this way. Because a lot of times when you work with direct variation, it's going to be linear setup on this one, and that's kind of what they're assuming in this case. So if you have these two values with your x and your y, to figure out what k is, k was y divided by x. Now come back up here to this part. Okay, so for a k value here, that's just 8 divided by 4. So our k value is 2. Good. And if they ask you to write let's just call this part A right here. If they ask you to write a equation of the problem, so if they ever ask you to write an equation for a specific problem, what they want you to do is you plug back in just the k value. Okay, because again, any kind of direct variation, the general equation is always y equals kx. But we know that k value is 2. So basically you take that k value of 2, and just plug it back in for your k. So that's y would equal 2x. And again, that way it looks like a linear equation, because again, in this case, your k value is kind of like your m value, it's kind of like your slope. And again, that can change based on your variables and how they're set up. But that's kind of the basic general idea of any time we go through this one. And a lot of times on this one, they'll do kind of like we did with the other problem ahead of that, is that something we'll do at part C here, is they may then ask you to find the missing value. Of the ordered pair with something like x10. Okay. And once you've got the equation, everything else is really easy. They give you one number, you can tell me what the other number is going to be that would be associated with that ordered pair. that you're going through. So for this one, again, there's your y value. So so now using that same equation we've got here, y is 10. We're trying to figure out what x is. 10 equals 2x. Divide both sides by 2. And in that case, our x would equal 5. Okay. And the good thing is, if it's any type of word problem with these, they have to tell you, they have to use the word inverse or direct in there somewhere, because if they don't use inverse or direct, you don't have any idea how it's used or what the equation is. So that they have to give you inverse or direct so that you know what to do with the equation that you're working through. Okay. All right. After that, they will give you some ordered pairs in a table form, and they're going to ask you, based on these numbers, is this inverse, is it direct, or is it neither? So you're going to determine the type of relationship. It's either inverse, direct, or really it should be none, or because it could be the third type we'll talk about here in just a minute. But there's only one. That one, there's no way really know. So it's either inverse, direct, or it's neither of those two. Because if it's the third type that we'll talk about in a little bit, it's a combination of one of the types we'll talk about here in a little bit, but it's just an extension of some of these, and it's got more variables in it. It's a little bit tougher to determine. So if you only have two variables, though, you can figure out if it's inverse or direct. If it's not either one of those two, then it's neither above. It could be the third type we'll talk about, or it could be just something else random that doesn't really fit anything at all. Okay, so anytime they ask you to figure out what the relationship is, you have to find k value. Because if they give you the ordered pairs, if you can figure out what the k value is, that's the whole key to everything. See, it's the k value, right? It's the key to the whole thing because it's the k value. That if you can get that part, then everything else will be okay. Oh, get it because it's okay.
Why do we always use K?
Because I think when the language it was first written in, when they were figuring this stuff out, they used K for the instead of like we use C and K kind of interchangeable sound wise. Their word when they wrote constant, they used K. So that's why we go with that part. So just like when we do natural logs, the original language it was log natural, so it was ln instead of nl, which is so a lot of this it goes back to the original language it was written in, and they just left it that same way. So, all right, so here we go. Here's example 1. All right, so we got a table of values. We can go 215. We'll go with 4, 7.5. Let's go 5, 6, and then 10, 3.
Sorry.
2 and 15, 4, 7.5, 5, 6, and then 10, 3. All right, if we're gonna here's your cheat sheet when you're working through these. If they give you this list, you're gonna do two things first. You're gonna take the x and the y values and multiply them together. If the k value is the same for everything, that's gonna be an inverse relationship. Yep. And if you take y divided by x, then that's gonna be direct. So again, if we're finding the k value, we're going back to what we were saying how to do it back here. So direct, it was y divided by x, and for inverse, it was k times, or k was equal to x times y. All right, so let's do the easy thing first. Let's do the multiplication and see if it's inverse first, because that's always going to be the easier thing to do. No, it either has to be direct or inverse. It can only be one of the two. All right, so the k value, let's go ahead and do the inverse first and see what happens. We've got 2 times 15 is 30. 4 times 7.5 is 30. 5 times 6 is 30. 10 times 3 is 30. K values are all the same when you multiply. If we do x times y. So again, if we're doing x times y, that means this thing has to be an inverse function, where the k value obviously is 30. Okay, and one other thing they might ask you to do on top of this is they may say, all right, now that you know that it's an inverse variation and the k value is 30, tell me what the equation would be of this particular relationship that we have here. Yep. So for inverse, that's y equals k over x. So that's y equals 30 over x, and that would be your equation. And we really only need that one because we're using that to kind of set it up there. So I guess one thing I should have put in the directions up here. Determine if it's what type of relationship it is, and if it's direct or inverse, then tell me what is the equation. All right, so for example 2. Let's go 0.2 and 8, 0.5 and 20, 1 and 40, and 1.5 and 60. All right, and sometimes you can look at it and get an idea of what's happening with it. Sometimes you're not, because again, sometimes the numbers look really good, but you really don't know until you actually check the numbers to get on this part of it. So first thing we're going to do for the k value is we're going to take the easy part. We're going to do x times y and see if we get the same number every time. Now, obviously, I think you can tell on this one, right? Because if you do half of 20, that's 10. If you do 1 times 40, that is 40. And if you get two different numbers, that means it's not going to work. You know, if you did 1.5 times 60, that would be what, 80? No, 90. If we do 0.2 times 8, that's just 0.4. And again, for it to be the same, all the k values have to be the same. And if there's two that are different, you don't have to check the other numbers. If you do half of 20, you know that's 10. If you do 1 times 40, that's 40. You don't need these other numbers. If that's 10 and 40, there's no way it can be x times y. All right, so that was checking to see if k was going to be x times y. This time, let's do it now. And for this one to work correctly, you have to do y divided by x. I mean, you can still get the right answer to know what type of relationship it is, but k value, if you don't do y divided by x, your k value is going to be wrong. So for this one, it's 8 divided by 0.2, which really, if you move that decimal over, that's 80 divided by 2. So that'd be 40. This is 20 divided by 0.5. And again, if you move that decimal over, move that over, that's 200 divided by 5. Also 40. There's where it gets easy. 40 divided by 1. Well, that's 40. And if we do 60 divided by 1.5, that is also 40. Okay, so doing x times y didn't help us out. So now we're going to check and see what happens if we do y divided by x. We get all 40. So we know the k value is 40. And again, if you're doing division, that means it's actually with the two variables. That means it's going to be direct. And so your equation would wind up being y equals your k value. And if it's a direct equation, the x values go directly beside the k value, so that's y equals 40x. Okay, so kind of going back to Emma's question on that one is there shouldn't be a way that it can be both. It cannot be inverse and direct at the same time, just based on two different variables. What you have, it has to be one or the other. And we'll show you a third one here. Okay. And then we're going to throw in a mix of positives and negatives because we didn't really look at the first two. And again, don't just assume because you've got positives and negatives that there's not a certain pattern that can happen, because it just depends on the numbers. All right, so we're going to take the easy route first. Check and see if we can do y times k and see if we can multiply those two numbers together to get the same thing. And again, you don't have to check every single number, because this one, what's half of negative 40? Negative 20. If you go the easy part, we've got 2 times negative 10, also negative 20. But you've got to check every single number. If you do negative 1.2 times 12, is that going to be negative 20? No, not even close, right? If anybody remembers your 12 times 12, that would be 144. So that would be like negative 14.4. So it's in the ballpark, but it's not really quite close enough. Just like you multiply these two together, it'd be negative 15. So they're all pretty close, but it's got to be the exact same number every single time. So we can't do y times x. All right, so we are going to check y divided by x. And again, if you just check a couple of them, if you do 12 divided by negative 1.2, that's negative 10. If we do negative 10 divided by 2, that is negative 5. So that's not going to work. So that means that one's out. So if it's not direct and it's not inverse, if it's neither one of those two, then they ask you what type of graph is it, or what type of relationship is it. No, that means it's going to be neither. Because not direct, it's not inverse. And it could be this third type that we'll talk about now, because this one doesn't just have two variables, it has lots of variables, possibly, depending on what's happening with it here. Okay, so now, and here's the big difference when we talk about these. We stick with just these two. Direct and inverse, if we look at them in just the basic sense, they always have just two variables, which we'll look at to use as x and y. The third type that we look at can have more than just two variables. So it's a little bit, it's not really harder. It's just that it's not as straightforward as some of the other things that we look at. All right, so the third type is joint variation. And for this one, it's basically it's an extension of direct variation. With more variables. And that's all that joint variation is. It's just taking direct variation. Instead of saying that this variable is the same as this variable, it's going to stretch it out so that it's extra variables multiplied by itself. So it's like if you're doing science, if you're in chemistry with some of the stuff, that sometimes pressure, trying to think of some of the different factors you have when you're doing temperatures, like pressure the pressure, the temperature, um, the density. You put all those things together to work with some of the different things you're doing in chemistry. This is kind of one of those same thing that it talks about more than just one thing that's here. So um, now there's not a basic equation on this one because it can be three variables, it could be four variables, it could be five variables. So there's not like one set way that this one's going to kind of go. So, all right. So what we're going to do for these, instead of just like solving different equations on this one, which we still could do, it's more of working, understanding how it's going to go through these. So that some of these are going to ask you to write some equations based on what variables and how they set this thing up. So we're going to do this. Write the equation where y varies jointly with temperature we'll call it T, and pressure, which we'll call P. Okay, in any of these that we're going to do, basically when you set this thing up, you've always got the first variable here, that's your Y. And whatever, because they're going to have to tell you the word varies in there somewhere. And the word varies, no matter what type of equation it is, whether it's direct or inverse or joint variation or whatever it's going to be, that little part of it, when you see the word varies, that's always equals K. So they give you the first variable, they give you varies, and they tell you how it varies, whether it's direct or joint or inverse, whatever it's going to be. But the word varies basically is just equals K part. That way there's always some type of equation that you've got with it here. And then everything after that tells you what to do with the variables. If it's jointly, it just means these two things are multiplied together. So they ask you to write an equation of it. It's just y equals K times T times P. Again, joint variation is just an extension of direct variation. So let's do another here. Let's do y varies directly with x squared. All right, so you got your y. Again, every time you see the word varies, that's your equals K. And then after that, the direct tells you where to go. If it's direct, you put it directly beside the K value. It's x squared. So in that case, it's just y equals kx squared. All right, two more and then we're done. All right, then we'll do y varies inversely with, let's go with the square root of t. Okay, you got y. Again, your varies is your equal k. And again, the next word tells you what to do with it. If it's inverse, that means that the next variable has to go underneath it. So it's y equals k over the square root of t. Okay. Now, and sometimes on those, after they give you, if it's direct or inverse, they may turn around and, or even with a joint variation, they may turn around and tell you, okay, that you've got to write an equation where y is 7 and t is 25, and then you got to work through. So they may give you values to plug back in. If they give you values to plug back in, you're basically just back to doing the same thing we were doing back in the beginning. You figure out what the k value is, and then you plug in some numbers and just kind of figure out what it's going to be. All right, so the last one. Let's go y varies jointly with the square of p. And the square root of t and inversely is z. All right. Again, wherever you see the word varies, that's your equals k. Because it's telling you how, because it's always equals k, and then after that, it tells you what you're going to do with it. So you've got the y equals. And then again, jointly basically is just direct variation, just stuck together. So it's jointly with the square of p, so p squared, and the square root of t. Okay. And then if they throw in inverse, that means that has to go underneath it. So then the z would go on the bottom.